Hello students, uh, welcome to one more problem of System Verilog series. So in this question we will be trying to solve a question based on deep copy and shallow copy. So before actually trying to solve the question, let's try to understand the concept of what actually does the deep copy and what does the shallow copy mean and how to implement in real code. So I have some uh, slides that I can show you, which can help you to understand this concept in a much more easier way, and you would also able to visualize how actually things work. So let's try to understand first thing is okay. So let's try to understand generally what does a simple copy method means or when okay. So let me just try to brief you about this slide that I'm presenting. So here we are having, you can just treat this packet P1 as a class, and in this class you can assume we have two members. One is ID. This ID you can assume it is of integer data type, and this is a HDR, another class member. This HDR is a object of a class which is present inside this class. And to understand the definition of HDR, this is the definition of HDR. This is which is nothing but a header. So you can consider this as a nested class. Nested class means that a class is been created inside a class, so which is known as nested class. So here this is HDR, and HDR is nothing but this HDR just has two fields, which is sequence ID and protocol. And this HDR, and okay, so this is the class name header, and this is its object name HDR. This HDR would be pointing to the location in which this actual header would be stored. What I mean is, okay, so let's first try to understand uh, uh, the copy methods. So here we create, first thing is P1. P1 is nothing but this. It has two field, ID equals to 1, ID equals to 1, a plain integer, and HDR, which is not a header object. It's a handle, a pointer address that tells System Verilog where the real address lives in a memory. So what does this line means is this HDR would be having the information of a point, would be having the information of a address. Is you can treat the HDR as a pointer which would be telling which has the information where actual class is been located. So this you can treat as an address in order to reach to this location. So to understand in a more easier way, you can think this handle as like a house address written on paper. The paper HDR is not the house header object. It just tells you where the house is. So this is just telling you where actual location, where the address of this header. So this AA you can consider one of the locations of a memory, and this location, in this location this header would be present. So HDR would be just holding the value of this header of this address. Now if we read more description, then here it's mentioned that copying the paper does not means a new house. It just copies the address. So even let's say if you copy the value of header, it doesn't mean that you are copying this header, this stuff. You are just copying the value of address. That's all. So this is just you can consider a basic concept of cello copy. This is generally how a basic cello copy works. And to give you a more okay, so this was just, you can consider the a class, how a class has been defined, and now we will understand how a cello copy comes into picture and how you implement it. So here if we call, okay, so here if we call p2 equals to p1 dot copy, but inside copy we write temp dot hdr equals to this dot hdr. This only copies address, not the header object. Now both P1 and P2 points to same address. Alright, so what this slides is trying to point you is, let's say this is the same class that we just saw in the our previous slide, packet P1, which is having two fields, ID and HDR. Let's assume ID is 1 and HDR is having address AA. And this HDR is nothing but this class in which we have two fields, sequence ID and protocol. Now you can consider that you just take two instances of this class packet. One instance name is P1 and the another instance name is P2. Now, if you are taking two instances, which means all the class members would be identical in both the instances. So here ID would be 1, so here also ID would be 1. Here HDR would be A, here also HDR would be A because you are just taking the two instances. What does that mean is here HDR, the value of HDR in both the cases are same, which means they are pointing to the same memory location. So let's assume if we have a memory and this HDR points to one of the locations of a memory, which is nothing but AA, and this also points to the same location. So let's say due to any due under any circumstances, if the value, if we change the content of the if we change the content at this memory location AA, then it would be reflected in both the instances of the class, that is P1 and P2. So here important thing to note is, if the original memory content which is located at AA is changed, then both the instances of the class is getting affected. So here, if we try to understand this point, then cello copy, which means that both shares the same header AA. If let's say you do temp dot header equals to this dot header, only copies the address, like photo copying is house address. Now you have two pieces of paper with the same address but still only one house. Change the house from either pieces of paper and both see the change. So this is just a simple way of correlating our shadow copy in a more realistic house example. So this is for the cello copy. So the important thing here to take away is cello copy means that here same HDR value is been shared across two instances of the classes. And let's now understand, when we are implementing a cello copy, then what sometimes it can lead to some issues which may need to which we should be aware of. So we need to aware when to use a shallow copy and when to use a deep copy. So this is a very good example of when you should avoid using the shallow copy and when you should use shallow copy and what are the consequences of using shallow copy. So here, this is the same example as we discussed in this slide. So here here, let's say here the it's the same class which is having ID and HDR. Again, this is also same. This packet 2 is also same. Okay, all right. So here what we are trying to do is we do p2.hdr.sequence ID equals to 99. So what we are trying to do is we are trying to access packet with the help of p2 instance. We have created two instances of this class p1 and p2, so we can access this variables with the help of any instance that we want. So here we are accessing ID with the help of p2 instance, that is p2.hdr and hdr.sequence ID equals to 99. So what I'm trying to do is I'm trying to change the value of sequence ID with the help of HDR handle, which is situated inside a packet P2. Now both handles point to the same object at which is nothing but AA location. Now here, as we discussed in our previous slide, that if you're changing the value of sequence ID and this sequence this ultimately this you can consider this stuff header is situated at this memory location, which is nothing but AA. So now, if you would access the value of sequence ID with the help of P1 handle, what does that mean is if you just print the value of p1.hdr.sequence ID, then instead of getting value 10, you would be getting value 99. The reason that you will be getting value 99 is you already changed the value of sequence ID with the help of P2 handle. And as this header is been shared across two classes, so and changing this sequence ID via any instances of the class would be reflected in the another instance as well. So here that's why it's written that P1 header also changes to 99 even though we never touched P1. This is a kind of a silent bug. So here when we say silent bug, it's not actually a bug, but you need to understand the concept that this is how this concept work. So if I take a real project example, then let's say if someone has developed this packet P1, and let's say if some another engineer has developed this packet P2, and the person who has developed P2, let's say if he changes the value of sequence ID via P2, then that same value would also be reflected when you access the value of sequence ID via P1, even though you haven't changed the value of sequence ID via P1. So you need to make sure that whatever you are change this as this header is common, whatever you change, it would be reflected in all the instances of the class. So if you have this use case in a project, then you can definitely go for this, but you need to make sure that this would be the consequences of using this copy method. So here a P1 is broken, we never touched it. So even we never you haven't touched the P1 object, but still its value get changed, like the HDR value. P2.hdr.sequence ID is 99 went to address and change sequence ID there. So here P1 here just they are trying to explain in a real UVM scoreboard this is nearly impossible to dig out the object looks modified but nobody assigned it. So here just it's kind of you should be aware whenever you're using this cello copy, then this is the concept and this is how it works. So now let's try to understand deep copy. So in a deep copy, let's say you are having that same instance of the class packet P1, you are having the same again P2. Let's say this is the same header that we discussed earlier, which is having a sequence ID and a protocol member. Now, let's say in P1 you have this HDR, and which again points to this 55, sorry, 80, AA, and AA is nothing but this. Now, the only difference in deep copy is when you take two instances of the same class, that is packet, the two instances named are again same P1 and P2. Then in this case, instead of sharing the same address, that is AA, here the AA was shared amongst P1 and P2, while in deep copy, this both the HDR is getting a unique address. That is HDR is this packet P1 HDR would be getting AA and packet P2 HDR would be getting BB. It can be any other address, but it won't be AA. So you can consider as there are two actual headers getting created, and because there are two headers getting created, both would be having their unique addresses, and their unique addresses would be pointed by the respective HDR values. So if you want to access this sequence ID, then the only way to access this sequence ID is by p1.hdr.sequence ID. And if you want to access this sequence ID, then the only way to access this sequence ID is by p2.hdr.sequence ID. And even if you change the value of this sequence ID with the help of P2, then it won't be reflected in this sequence ID because they are actually located into different memory locations. Their memory locations are not shared, it's a unique location. So let's say if you have this kind of requirement in which you don't if you change the value of sequence ID via any one of the instances and and you won't get it to be reflected into another class, then you can use the concept of deep copy. So here in deep copy, there are two packets, two independent headers, and two both are having the unique locations, same field value, same addresses, like building a second house within the same blueprint to completely separate buildings. So now one more important point here is to implement a deep copy and a shallow copy, there is some particular type of syntax that you should know in order to implement this, how to do this, and how to implement a shallow copy that we would be discussing when we would be trying to solve a real problem in System Verilog. So it will be our next step when we go to the problem. But just uh, going to the last slide of the this presentation. So here if we do p2.hdr.sequence id equals to 99, this time it gets modified bb only p1 header at a stays untouched. So this also is the same whatever we discussed. If you just change the value of sequence id here to 99, it won't be reflected into this sequence ID as they both are unique. They both are having a unique addresses. It's a different locations altogether. So it's not possible to get overlapped. So this was a basic concept of how generally a copy of shallow copy and deep copy works in System Verilog at a fundamental level. Now we will see how to implement this in our real codes as well. So let me try to walk you to first example of shallow copy. So let's assume you are having, so I'm trying to take that same class example and the same variables will be tracking that we just discussed in that slides. So here, let's assume that you are having this class which is having two fields, nothing like which are having two fields. One is ID and one is a header. Header is a class which is defined over here. So it's you can treat this header is a nested class. Basically, it's a class which is defined inside a class. Header is defined inside a packet. So for the header, you have again two fields that is sequence ID and protocol. And at line number 5 to it, you can just consider it for some copying. If I want to update the value of sequence ID, so I can directly update the value of sequence ID and protocol by just copying the new method of this header. Okay, all right. And same for this function as well. If I want to update this ID, I can just update it by calling the new function and just passing the values of whatever I want. So, okay, all right. So now our task in this problem is to implement a copy method such that it actually does a shallow copy for us. When I say shallow copy, what does that mean is when you okay, first let's try to understand this problem description. It would be more easier for you to understand this code later. So here, let's say first you implement a copy, so it returns a new packet, but the HDR inside the copy should be the same header. What it tries to say is the HDR inside the copy should be the same header. This is the HDR inside this copy should be the same header. Do not create a new header, which means this. Your copy must return a new. Okay, so this is very important. The copy method, what the exit, the copy method should do three things. First is return a new packet, not the same handle as this. So whenever a user calls this function, it should return a new packet. It should copy ID directly, and it should assign HDR by handle. So uh, where there are also some examples given on how what can be what can be called as a correct output. So let's say if you just update the value of ID to 1 And let's say if you update the value of sequence ID, that is this sequence ID to 10 and the value of protocol to AXI, and then this is the syntax or line that you can use to like this would be a part of our TB. If you see a test bench as well, this is just you call this method. So let's say when you call this method, let's say via a P1 handle, let's say if you call P1.copy and assign that handle to P2, and if I print the value of P2, then the P2 should have all the fields that are a part of P1, that is ID1, sequence ID 10, and protocol SAXI. Here, as we discussed, the HDR header uh, would be having a 55 location. So here, as we just saw here, let's assume this is a HDR header, which is nothing but let's assume it could be pointing to a address, which you can treat this address as anything. Here we are just taking AA. So this address is AA, and if you declare one more instance, this would also be having AA, which would be the same instance. So if I go back to our original problem, so here header, yeah, it's same. It's you can say that P2 now has the same header as P1 as we just saw in that slides. And now when you change the value of sequence ID via P2, so you are taking two instances of a class and now you change the value of this sequence ID via help of P2 handle. Let's say you change to 99. Now this 99 would also be reflected in when you access the value of sequence ID via P1. So this gets also changed. So this is like how a seller copy works. So now our task is to first implement this seller copy. So seller copy is very easy to implement. Let's try to code this. So here let's take a you can just take a temporary variable, and then what you need to do is you can just update temp dot sequence ID to this dot. What we need to do here is you just need to update the value of uh, we can just see the test bench as well, how the test bench has been coded. Alright, so here if we first we are passing the value of P1. Okay.